Hi everybody, so today we have this problem on infinite geometric series from the HMMT, the Harvard MIT math tournament. So this problem was presented by Isabella Quan and it was presented, I believe, in the November 2023 tournament. So I am here today to help explain its solution. So here we're dealing with infinite geometric series. So if you can't read the problem well, it is in the description down below, so you can pause and go check that out, but I'm going to read it now anyways. So Tyler has an infinite geometric series with sum 10. He increases the first term of his sequence by 4 and swiftly changes the subsequent terms so that the common ratio remains the same. Create a new geometric series with sum 15. Compute the common ratio of Tyler's series. So we're going to go ahead and start. So first of all, I'm going to write down the equation for the sum of infinite geometric series. So it is defined by this formula over here, where S is the sum of the infinite geometric series, A is the first term of the series, and R is the common ratio. So R is essentially what we're trying to find. So what we're told here is that this series, so the original series that we have here, has a sum of 10. So S is 10. So I'm going to go ahead and write that down. So 10 is equal to A over 1 minus R. So this is our original series. But again, we have a different series. We have a second series where, as we can see here, he increases the first term of his sequence by 4 and its geometric and its sum is 15. So if we write down that down in a formula, we get 15 is equal to the first term increased by 4, so A plus 4 over 1 minus the common ratio. So these are the two equations we're dealing with. So this is the system of equations that we have, and we're going to go ahead and try to find A first in order to find R. So we do that by dividing the two equations over each other. So 15 over 10 is equal to, so it's going to be equal to A plus 4 over 1 minus R over A over 1 minus R. So 1 minus R and 1 minus R are the same, so we can just go ahead and simplify that out to A plus 4 over A. You could go the longer way and do A plus 4 over, like, you could write it this way too. This is what I mean. But this is basically this simplified. So we're going to go ahead and use simple cross multiplication here. So 15A is equal to 10 times A plus 4. We simplify that further. 15A is equal to 10A plus 4D, subtract 10A from both sides. We get 5A is equal to 40 divided by 5 divided by 5. We get A is equal to 8. So the first term here in the original series, in the original infinite geometric series, is 8. So this is A is equal to 8. So we're gonna go ahead and plug that back into the original equation for the infinite geometric series. So remember, this right here is the original equation. We could also plug it into this over here. You'd get the same answer. So I'm gonna go ahead and do that. Okay, so A plus 4. So it's, I'm going to go ahead and do this since it's simpler, since we're dealing with less variables. So A is equal to 8. So first of all, I'm going to do 10 is equal to 8. As we're told, A is equal to 8 over 1 minus R. Remember, this problem is asking us to compute the common ratio. The common ratio is R. R is equal to common ratio. So obviously, what we're going to try to do is to isolate the R variable in this equation. So I'm going to go ahead and do cross multiplication. So 10 times 1 minus R. So that gives us 10 minus 10R is equal to 8. So I'm going to go ahead and subtract 10 from both sides. Minus 10 minus 10. We get negative 10R is equal to negative 2. So we're going to go ahead and simplify this even further by dividing both sides by negative 10. So we're dealing with two negatives here. So R is going to be equal to 2 over 10. And we can simplify this even further. 2 over 10 can be simplified to 1 over 5. So this is the answer the common ratio of Taylor series is 1/5. I hope you guys enjoyed this video where I'm dealing with the problem from HMMT on infinite geometric series. Do not hesitate to comment on any suggestions you might have or any problems you might want me to solve, and I hope I'll see you guys soon.